Hi, I want to talk about a subject that have been of academic interest to me for a very long time. And actually, I took some courses in propulsion and rocket technology in Cal State Long Beach. Uh, Even though I did very poorly, I got a C. I have been very interested in this subject. This is of most important value to me because I think that humanity will find very many interesting things in the space outside of our planet Earth. We are really living in the bottom of a gravity well that is very hard and expensive to get out of and find other places to live or do research or work. Um, but before I start going to an idea that has been of interest to me, I would like to ask you to be honest with yourself and ask yourself if you watched this video and found an original idea, okay, would you be so honest to give me an intellectual credit or scientific credit for it instead of just taking it in and putting it under your own name or under a company's name? Because I have trouble with this problem. Many of my ideas are very original, very valuable, and people just look at them and just take credit for them and never even mention my name. And this is troublesome. Uh, so, I mean, if you are a researcher and you come across this video and you didn't hear these ideas from anybody else, okay, does that mean that this is an original idea or conception or design? You should, in all honesty, give me credit for it, right? I mean, that's only fair, right? Alright, so the, the the issue with the rocket technology and orbital technologies was that most of these technologies were geared to escape the gravity well of the Earth. Okay, to escape this gravity well, you have to spend a lot of energy. Okay, it's not that simple. There is the planet Earth has a lot of mass and attracts and keeps us prisoned at the bottom of a well. We are really living at the bottom of a well. To get out of this well, you have to spend a lot of kinetic energy or whatever form of energy, potential energy. Energy is energy. Okay, you have to spend this energy to get the hell out of here. Okay, it's not that simple. Now the traditional way that many uh, space agencies try to get out of this dilemma is to use rockets, and there's a tremendous instantaneous impulse or specific impulse that's given to a given kilogram or a pound of mass to get the hell out of here. Okay, it's not cheap. The price per kilogram or pound of mass to get it into orbit is exorbitant. So there are other systems besides rockets, but many of them they have really never taken off because they're too intricate and too complicated. There are some designs for space elevators and tethers and all that. Okay, so I mean, what I'm going to tell you is a special design. Okay, that will facilitate or make it cheaper to give a kilogram of mass enough energy but not to use rockets, to use other technologies. And it's doable. It's not fantastic, or you don't need special materials or this and that. Okay, it is doable. And when you hear this, do you, in all honesty, in your mind, think that this is an original idea? Okay, just be honest with yourself. Is this an original idea? And do you need to mention my name and not to just take credit for it yourself? Okay. All right. So the thing is that when a rocket is launched into space, a lot of the specific impulse or the energy that's given to the final stages of this rocket is really spent in the first stages. Most of the fuel is spent when the rocket barely launches off of the surface of the earth, okay, and goes like so many miles off the earth, right? So this energy, it translates into mass, okay. Most of the energy that comes from this launch comes from burning of hydrogen with oxygen, but the hydrogen that's used is not simply hydrogen. Is a hydrogen that's trapped in the molecular structure of other fuels, like it's trapped in the molecular structure of methane or anything that has a lot of hydrogen in its molecular structure. Okay, so really you are not getting all the specific impulse, all the kick that you really need out of this hydrogen, because it's still got some bonds with carbon or nitrogen or other stuff. Okay, you're getting like the part of a cake, not all of it. All right, so that's what the rocket scientists think about specific impulse. But this specific impulse is only partial. Well, NASA had a space plane. They usually call it X this or X that, X-37, X-38, X, whatever. So the problem they had was that they had tried to use only hydrogen as the fuel, or hydrogen and oxygen as the fuel. And the problem with storing hydrogen is that hydrogen is basically just one proton, and the proton, it knows how to infuse into any outer layer that's enclosing it. Say for example you're using plastics or steel or whatever, the hydrogen will sneak into the structure of this wall and do all kinds of funny things with it, corrupt it. So they had leakage with the hydrogen, and the tanks were not good. They were troublesome, and so the space plane wouldn't really work out very well for the same reason of storing hydrogen. I mean, if you're storing oxygen molecules are much bigger than hydrogen molecules, and you can store them because they will not interact with the wall that's enclosing them. But hydrogen is a different story. So it's really a challenge to build a container that will contain this fuel that's called hydrogen, and having such a fuel is the way to get the most bang or most specific impulse for that fuel. Say for example you had a tank of oxygen molecules and you had a tank for hydrogen molecules. It would be better if you had it would get more specific impulse than if you had instead of hydrogen you had like a hydrocarbon, because the hydrogen would be trapped in the molecular structure of the hydrocarbon and you wouldn't get as much of a kick as you had just the hydrogen. So you get my point, okay? Anyhow, what I would like to tell you is that if you don't have a very good head on your shoulders, you will not get this video. You need to be very smart and very educated to understand these subjects. Anyhow, so I'm proposing a system, okay, that we can capture all the specific impulse of hydrogen and also give a pod or a vessel enough energy to make it basically space worthy, to use those specific impulse from hydrogen. First of all, the idea would be to build or find materials to build a container that can contain hydrogen and will not break down, it will not get corrupted. The hydrogen is very corrosive and will get into the molecular structure of whatever that's holding this fuel. Okay. The other concept or idea is to give this pod enough energy on the surface of the earth, so you don't have to spend as much fuel to get it up and going into orbit. Okay, so I mean, say you need Mach 13, but most of the fuel is spent to get to Mach 1. Okay, basically most of the mass of the rocket is just to get off the surface and get it going. Okay, so what I'm thinking of that this design would be is to use hyperloops to give this pod enough energy, you know, and it's still bound to the earth and it's going through a hollow cylinder. It's going through, but all this energy is imparted into the pod and the hydrogen fuel that's in it before it even gets out of this cylinder and gets into the atmosphere. You follow what I'm saying? I mean, so it's kind of possible theoretically to cut back on the amount of the fuel a rocket would need to launch into space by giving the energy to this pod before it even launches, before it even gets into the air, and then once it gets into the air with at least a Mach 1 or less, then use the very hard punch from oxygen fuel and the atmospheric oxygen. Basically, this is just the pushing the concept of rocket to the most extreme limits that it could go. Basically cutting back on the fuel for launch, like 60, 70, 80% of the fuel of the launch is just cutting back on it and having this electromagnetic circles just propel this pod with the fuel to Mach 1, and then once it gets out, using the very high specific impulse of the hydrogen to reach escape velocity. These ideas are kind of hard to get for somebody who hasn't studied orbital mechanics, but you just have to kind of research it out in Wikipedia. There is escape velocity, but it doesn't mean that you have to put all your fuel into the same rocket. You can have two stages. One stage is that the pod or the rocket is in this tube, and all the energy for launch, most of the energy for launch is provided by electromagnetics magnetics or by other mechanism that just imparts the energy to this device or this pod, and then the final Mach velocity is reached by the hydrogen. It's just extending the same ideas that have been around to the higher level. I mean, that's the basic of this original idea. Anyhow, I hope you like my video. These ideas are new. I haven't seen it in any other publications. If you use them, please give me credit for them because I came up with them. All right, and especially the fuel hydrogen is would be essential because it gives it the final kick. That's a very high kick to reach Mach 13 to escape velocity. You cannot use regular fuels to do this because the weight will be just way too much. If you use carbon like methane with a lot of hydrogen in the molecular matrix, it will not work because most of the energy is going to be wasted in carbon. You need hydrogen, the oxygen, to get that high molecular bond energy, to get that very high kick. Also, you need to economize in the cost of propelling this pod and the fuel to the levels that will be economical. I think if there is a quantitative analysis to this that I think would be very complex. I don't have the software to go through it, but just suffice to say that most of the energy that to launch a rocket into space is wasted in the original level of just getting this thing up into the atmosphere, giving it enough velocity. The first stage wastes a lot of fuel, and or the second stage, I mean, if you could economize in these two stages and have the energy given to it by Mach train or by a pod that's accelerating inside the tube by different mechanisms like levitating pod, and using electromagnetic rings to just propel it to this speed. That's all that matters, because the only things that matter is that this pod and the final fuel that's getting out there has enough energy. That's all that matters. Theoretically, the energy to escape is the only thing that's of the essence. Anyhow, I would like to emphasize to you that I would like to get credit for these ideas. They are not old ideas, they are new ideas. If you read them and saw this video, you should give me credit for them. Okay? And what else I want to tell you? I am fascinated by this subject, and I think that these systems will take off in one form or another. Thank you.